All right, hi guys. This video is for my pre-algebra class. We're going to be starting with section 2.3, which means we're going over the distributive property. I need you to make sure that you have your textbooks with you as well as scratch paper. We're going to be working through some of the skill checks, but we're also going to be working through some additional problems that are not in your book. So as usual, I'd like for you to write those down so you have the examples in front of you when it comes time to doing the homework and studying for the quizzes. So have your book open to page 55, and we'll get started on that section 2.3. Let me go ahead and share my screen, and we'll switch to the whiteboard. Let's see here. Okay, thought I'd give you guys a break from the black background. I'm not sure how well that worked with your phones or computers that you're working on, so I thought this might be a little bit easier to see. Sorry, having a moment here. Okay, so pre-algebra, section 2.3. Now, what they give you at the very beginning of this is they give you the definition of the distributive property, which means that for any integers, a, b, and c, that a times b plus c gives you the same answer as a times b plus a times c. So to start off, I want to give y'all a couple of examples of how we can do this to mentally calculate answers for fairly large multiplication problems. So if you look at lesson one, or excuse me, number one of the lesson opener, you have 5 times 20, which some of you I know do this because you can get your multiplications really fast. But you know that anything times a 10 number, so 10, 20, 30, 40, you just put the 0 in the end and then multiply 5 times 2, which gives you 10. So you know that 5 times 20 is 100. And then if you look at 5 times 7, if you've memorized your multiplication tables like you should, you know that 5 times 7 is 35. So 5 times 27 is really just 100 plus 35, which is pretty easy to calculate in your head, just 135. Okay, so then if you see 5 times 27, then in your head you can say, okay, 5 times 20 is 100, and 5 times 7 is 35. So my answer is 135. You don't have to work it out longhand like this, calculating your numbers and carrying everything and blah, 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 blah. Not that I did that right, 13. Anyway, you can do it mentally. And I know some of you already do that, so this is going to make a lot of sense to you. But for the others who've never really seen this, practice it with some large numbers and sort of go through your multiplication tables and make sure you're familiar with those. Okay, so our second example here is 3 times 23. So know that 3 times 2 is 6, and then you just put a 0 on there because it's 3 times 20. 3 times 3 is 9, and then 60 plus 9 is 69. So that means that 3 times 23 is 69. And so being able to sort of break those apart, you're essentially doing the distributive property in your head by doing 3 times, it kind of works the same. We call it something different, but you're separating it so that 3 times 23 is the same thing as 3 times 20 plus 3 times 3. Okay, so let's do it here with 7 times 82. Well, we know that 7 times 8 is going to be 54. And, 56. So you have to have your multiplication tables memorized. Okay, 7 times 8 is 56. And so you throw a 0 on there, then you know that's 560 is 7 times 80. And then 7 times 2 is 14. So then you know your answer is 574. So that's a way to try to practice that, do it in your head. So then you know that 7 times 82 is 574 without having to work it out longhand. Okay, so go ahead and look back on your books. Let's go through some of the examples that they give you for the distributive property on page 55. Some things that I want you to notice, they show in the first example 3 times 2 plus 5 is the same thing as 3 times 2 plus 3 times 5. Or you can say that 3 times 7 equals 6 plus 15, and 21 equals 21. So that's just a proof that the distributive property works. You can also do it with with subtraction. So because we know that subtraction really is the same thing as adding the opposite, it works just as fine. So you're really just adding the opposite. Okay. You can look at example 1 at the top of page 56. They ask you to use the distributive property to write an equivalent expression and then simplify if possible. So for example A, obviously we can solve this because it's all integers. But we have -5 times 2 minus 7. And so you would separate that out, -5 times 2 minus -5 times 7 gives you -10 minus -35. And we know that anytime you subtract a negative, that becomes a positive. So this is -10 plus 35, which equals 25. Now also with B, we have two variables here, so we won't be able to simplify them into an actual answer like the first one. But just know that 4 times m plus n is equal to 4 times m plus 4 times n. So let's go ahead and work through our skill check problems. I suggest that you go ahead and pause the video and try to work through these on your own, see how you do, and then check your answers with me. And I believe you also have them in the back of your book, but if you want to see the process, then work on them and then continue on with the video. So in number 1, we have -5 times x plus 6. So again, the distributive property says this becomes -5 times x plus -5 times 6. So we know -5 times x stays the same. We can't simplify that anymore. And we know that -5 times 6 is -30. And so that gives you your answer. You would simplify this one way though, because you don't want to have two signs next to each other if you can possibly help it. That's very confusing. So you could change this to -5x minus 30. Because like I said before, subtraction by definition is just adding a negative. So you can take that adding a negative and turn it into a subtraction. And it's more of what we're used to. Okay, so number 2, same thing. -4 times 3 minus -4 times y. So -4 times 3 is -12. And whenever we know that -4 times y is going to be -4y, but you don't want to subtract a negative. You can go ahead and simplify that to -12 plus 4y. Okay. Number 3. So 3 and 4 are all integers. So go ahead and solve these. So we have 8 times 12 minus 8 times 4. Do that either way. So 8 times 12 is 96. 8 times 4 is 32. So you're left with an answer of 64. Excuse me. All right, and the same thing with number 4. So distributive property says that 6 times -4 plus 2 is 6 times -4 plus 6 times 2. Well, 6 times -4 is -24 plus 12. So we're adding unlike integers here, so you find the difference in the absolute values of the two, and your larger number is your negative, so you know your answer is negative. 24 minus 12 is 12. That's a really large negative. There we go. So your answer is -12. All right, so in this Second, well, let's see here. Did I ignore those? I did. Go ahead. If you look at number 5 and number 6, then it's asking you to use the distributive property to calculate. So what's 5 times 7? 35. Well, it's 5 times 70, so you throw a 0 on there. So 5 times 70 is 350. And then we know that 5 times 6 is 30. So your answer is 380 because that's 350 plus 30. Let me go ahead and do these to the side. Sorry, guys. This is number 5 of skill check 1. They give you 5 times 76. So you try to use the distributive property mentally to do this in your head. Like I just said, 5 times 70 is 350. 5 times 6 is 30. And so your answer is 380. And then number 6 was 9 times 58. You know that 9 times 5 is 45. So throw a 0 on there is 450. 9 times 8 is 72. And so you're left with 522. Okay. Okay, so one thing I want to make sure that you guys understand, so I want to introduce it to you now, and then we're going to go much more in depth in this when we get to chapter 4. But the opposite of, or excuse me, the distributive property done backwards is called factoring. And this process becomes very, very important when you start to work with algebraic expressions in more detail. So what it's saying is that AB plus AC equals A times B plus C. So what you need to be able to recognize here is the fact that A is your common factor in both of these. And so you can take A out and you've created two separate terms that you're multiplying together. So just be aware of that. And right there in the middle of page 56, you might even want to highlight that where they've given you the AB plus AC equals A times B plus C. All right, so let's get some more examples here of using the distributive property. In example 2, they've given you 4 times -8 plus 4 times 32. So when you look at this, you actually see that you have a common factor, which is 4. I haven't left myself any room here. So, but you have these in here. So you can see in the answer section that they've separated that, taken that 4 out. So they have 4 times -8 plus 32. So they've sort of done the backwards distributive property here. All right, and then B, they have -3 times 7 minus 3x. So here your common factor is -3. And so you take out the -3 and you're left with -3 times 7 plus x. So remember, when you take out that -3 from the second part of that mathematical expression, you're left with a 7 plus x, not 7 minus x. All right. So let's do some more practice here. So skill check 2, they have you to use the distributive property to fill in the blanks. Again, go ahead and pause the video and give these a try and see how you do, and then check your answers. This should be fairly simple if you can look at the examples we've done previously. All right, so to check these answers, we know that 5 times x plus y equals 5 times x plus 5 times y. And then number 2, we're doing this backwards. We're actually factoring out a number. So you're given 4 times 3 plus 4 times 5 equals 4 times 3 plus 5. Okay, and then 3 tells you that 3 times 2 numbers added together equals 3 times 2 plus 3 times 7. So you can see they've given you your numbers here, and you can plug those right in. 2 and 7. All right, number 4, you should have gotten 9x plus 2x equals 9 plus 2 times x. Just carrying over your integers. Okay, and then they've asked us for number 5 and 6 to use the distributive property to write an equivalent expression. So first they've given us 2 plus 3 times y. So what's something that would equal the same value if you knew the value of the variable y? And this would be 2y plus 3y. And then they have us factoring in number 6. So we're using the distributive property backwards. You have a common factor in both of these. You have the number 3. So this is 3 times 4 plus 6. Okay. Hopefully so. Okay, so I have some additional problems for you, and then I'll give you your homework assignment so that you can get some practice this afternoon and this evening. And then we'll have another video where I go over those answers. So in the 1 through 4, what we'd like to do is write an equivalent expression using the distributive property. This is exactly what we just did in skill check 2. So 6 times 3 plus 5 is the same thing as 6 times, well, I'll do this in red so you guys can see your answers. Okay. We have 6 times 3 plus 6 times 5. And you would simplify this to, I mean, you can always solve it, but this becomes 18 plus 30, also known as 48. But right now we're just writing the expression. Okay, 7 times x plus 4 is, you distribute the 7 into the two numbers being added together. So we have 7x plus 7 times 4. I didn't give myself quite enough room here. Okay, so 7, and then we know that 7 times 4 is 28. So this would simplify more so into 7x plus 28. Okay, number 3, we have n plus 10 times negative 4. Again, it doesn't matter which side your factor is on, but you just factor it right in. So we have negative 4n plus negative 4 times 10, which simplifies into negative 4n plus a negative 40. Don't leave it like that, though, right? What does this really? Adding a negative number just means that you are subtracting. So negative 4n minus 40 is where it's at. Okay, and the last one of these, we have negative 8 times negative 3 plus negative 8 times z. This simplifies into negative 8 times negative 3 is a positive 24. Plus, well, and then negative 8 times z just becomes negative 8z. Okay. All right, so let's practice calculating mentally again. So again, take a look at these. Go ahead and pause the video and give them a try on your own. I'd like for y'all to keep practicing doing this. This is just a good practice to have to be able to do things mentally in your head. Besides, it's good for your brain. Come on, guys. So hopefully you've paused it and you're coming back now. So this is, think of it very simply. Anything times a 10, a multiple of 10 is just, like in the case of 4 times 20, it's just 4 times 2 and add a 0. So 4 times 20 is 80. 4 times 40 is 160. So then you have 80 plus 160, which is 240. Or like in number 6, you can use the distributive property. Well, you know that 3 plus 6 is 9. So this is really just 9 times 9, which again, if you have memorized your multiplication tables, you know very quickly is 81. Now in number 7, you know that negative 8 times x is just negative 8x. We don't know what x is, but what's 8 times 7, or excuse me, 8 times 9 is 72. So this is negative 8x minus 72. And then negative 5 times a minus 25. All right, use your brain cells here. Come on, guys. So negative 5a is the easy part, right? So 5 times 20, we know is 100, because 5 times 2 is 10. Throw an extra 0 in there is 100. 5 times 5 is 25. So 5 times 25 is 125. Now, in this case, you have a negative times a negative. So this is plus, terrible plus sign, plus 125. Okay. If you're struggling with that, go back to your multiplication tables, practice them, write them out. Get yourself familiar with them. It'll make this a whole lot easier. Okay, so in number 9 and 10, again, we're just getting a refresher on our properties. So if you look at number 9, you have 6x plus y minus 9 equals 6x plus 1y minus 9. So obviously this one has sort of an understood number in it. What you're seeing here is the identity property of multiplication. Because what we know is that any number times 1 equals that number. And that's what you're seeing here. That's why we don't put a 1 in front of a variable. It is understood that the number in front of that variable is a 1. Excuse me. Okay, and so 10, we are saying that 24m plus 9n equals 3 times 8m plus 3n. Hopefully we've gone through enough of these that you recognize this one. This is the distributive property. It is the distributive property backwards, but you still see how both 24m and 9n have a common factor. They have the factor 3 that divides evenly into both of these integers. So you pull that 3 out and you're left with 8m plus 3n. I know at this point that seems unnecessary. Trust me, as we move more into the algebra portion of pre-algebra, this is going to make a whole lot more sense, but you need to be able to understand how that works now. Okay, so that's all that I have for you guys, and that should cover or give you an example of everything that you're going to be seeing in your homework. So I want you guys to go ahead and try your homework assignment, which is due on Friday, and I will have a video where we go through that. You need to do numbers 2 through 44 even. This is also on your homework, on your lesson plans assignment that I sent home with everybody. These are on pages 57. I think it's just 57 and 58. Yep, 57 through 58. So give numbers 2 through 44 even a try. And once you're done with that, you can go ahead and watch the video, check your answers against the answer sheet. Your parent should have that, or watch the video to see how I work through those. All right, so hopefully that makes sense to you guys. I always liked the distributive property. I thought it made a lot of sense. So hopefully you'll find the same. As always, reach out to me via text or email if you are completely confused about any of this, and we can work one-on-one a little bit. This is an extremely important property that I hate you guys are having to learn on your own while we're during quarantine, but hopefully these videos are going to be a big help to you. So let me know if you're still struggling. I'll send you some more work. We can set up a Zoom call and work together on some of these until you feel like you understand it. All right, until the next video or the next time we're in class, I'll see you guys later. Bye.